Okay, hello everybody. So in this problem, we're supposed to draw contour plots and graphs. And so these are two of the main ways of visualizing maps. Also vector fields sometimes is another way to visualize maps, but this is just about contour plots and graphs. Okay, so part A is the map. I'm just going to copy it, x1, x2, maps to x1 squared plus x2 squared minus 3. So this is just a real number built out of two real numbers. And so what's the contour plot? The contour plot happens in the input space. In the input space. So that's R2 in this case. So let me draw some axes for R2. And let's see, in this case, this map is very much related to circles. So the preimage of 0 will be the circle of radius root 3. So like if this is 1, this is 2, then maybe root 3 is somewhere in here. So all these points on this circle are mapped to 0 under this map. Okay? What about the ones that are mapped to 1? So the preimage of the point 1, so 1 is a real number, and the preimage of the point 1 are all the points satisfying this equation, which if the minus 3 comes over here, it becomes a 4. So this is radius of, or circle of radius 2. So I'm going to sort of label this. This is the preimage of 1, whereas this circle is the preimage of 0. And actually, every point on this, I sort of visualize like there's a 1 hovering above every point on this circle, whereas every point on this circle, each of those points have a 0 hovering above it. This point right here, 0, 0, is 0 plus 0 minus 3. So that is in the preimage of 0 plus 0 minus 3 would give minus 3. So this is the single point, and hovering above it is the point, is the number minus 3. So every point in the plane gets a real number hovering above it, and the contour plot draws the preimages of outputs of real numbers, also called level sets. Okay, so I drew a few level sets here. They are a circle, and a point. And there's other level sets, and they're all circles. Now what about the graph? The graph happens in input cross output, so it's in a bigger space, in this case R2 cross R, which is 3-dimensional space. And so if I put let's say this is the x1 plane, this is the x2 plane, and then this is a new plane, a new dimension to represent the output space. Well, then height -3 has one single point. Only one point has a -3 hovering above it. And so 1, 2, minus 3. There's a point on my graph. Now there's a whole circle of points with a 0, and that's this circle of radius square root of 3. And there's a whole circle of points, a bigger circle of points with a 1, with 1s hovering above them. And so that gets, height 1 on this drawing. And so actually what we get is here like a bowl shape. And so the graph is the bowl. There's all these, each of these bigger and bigger circles gets higher and higher on the bowl. Okay. So draw a contour plot and a graph for A. So we did that. Okay, let's do B. So B is a map from R3 to R. Okay, so that's the map. Let's go to B. B sends, what was it, x1, x2, x3 to the point x1 squared plus x2 squared minus x3 squared. Okay, so this is the map in B. Yeah, I'm just making sure I copied it down correctly. So right away, they both together are going to give R4. So can't draw the graph. Sad face. Okay, but then we're actually happy because we're done with that piece of the problem. But now the contour plot. Contour plots are usually thought of as happening in the plane, but in this case the input space is R3, so actually this contour plot is occurring in R3. And what do we draw for a contour plot? We draw the preimages of specific outputs. And so actually, to help me with this one, I'm going to step down a level and think of the map x squared, minus y squared. This is xy goes to x squared minus y squared. And I just want to draw the contour plot for this first so that I can get an idea of what's going on. X squared minus y squared equals 0 is these two lines that come together at a single point. A sharp, this is actually a singularity we'll learn later. X squared minus y squared equals 1, so this would be like, I'm going to draw the preimage of 1. These two lines here were the preimage of 0 for this map. So 0 is a point here. What are all the points that get sent to 0? Well, it's the points that satisfy this equation, which are these two lines in this case. Now, 1, the number 1 is, it should go this way. 1 is a real number. So the preimage of 1 are all the points that satisfy this equation. And let's see, so 1, 0, if I plug it in, I get 1 squared minus 0 squared, and that does satisfy the equation. So that's how I remember that this, and also there's a second piece over here because the point minus 1, 0, when I plug it in, also satisfies this equation. And so actually, why don't I do that in a different color? So the preimage of 1 looks like this and this. And this comes up often enough in physics and math problems that you should just get familiar with this example and your life will be easier. So that's why this problem is here. Okay, so let's take x squared minus y squared equals minus 1. So what's the preimage of minus 1? What are all the points that get sent to minus 1? They're all the points that satisfy this equation, preimage. And it turns out that it'll go like this way. And there's another half down there. Okay, and now this just helps me remember because so this was just all sort of in my head. And I think you should play around with this in Desmos.com, for example. It's good for 2D, or GeoGebra.org, I think is the website. And then GeoGebra.org has a 3D website, and that's where you'll need to go to get the preimages of points here. So the preimage of the point is also like all the points that satisfy the equation. So the preimage of 1, what's the preimage of 0, what's the preimage of minus 1. And what we end up getting is that the, let's do it in the same colors, the preimage of 0 will be a cone. Like this. That was a terrible drawing. How do I... Well, anyway, it's hard to draw in 3D, but this will be the the preimage of 0. So you should go ahead and figure this out. And this is what the answer is. Okay. And let's see, what's the preimage of 1? I did it here in purple, so actually what we're going to get is like something like this. It's sort of, this is called a hyperboloid of 1 sheet. And it's sort of this surface here. And it's smooth. It doesn't have this singular point. It sweeps out like circles everywhere. And this is the preimage of 1. And now in pink we did the preimage of -1. And what you should check is that the answer has like 2 pieces. There's a piece up here and a piece down here. And so this is called a hyperboloid of 2 sheets. And you should absolutely go to GeoGebra.org/3D and see if you can get a sense of these preimages of -1. So this is the contour plot. This is the answer. Okay, let's do the next one. And I'm just reporting the answer, but you should really play with this and convince yourself that this is what's going on. And this is a good example for the future because, for example, this is the light cone in physics, this preimage of 0, and it's also demonstrating like changes in topology as you sweep through these preimages. As at first, when the purple thing is one big connected piece, then there's a singularity occurs, and then the whole geometric object splits into these upper and lower pink halves. So this is a really good example to know. Let's do C. C is x goes to x squared. So C, the map x goes to x squared. And so that's a map from R to R. And the contour, well, again, contour plots are usually in the plane. But again, the contour plot here is always the input space, lives in R. The graph lives in input cross output, which is 1 plus 1, will be in R2. So let's actually do the graph first in this case. So here's my x, here's my output, and the graph looks like something like this. Okay, there's the graph. It's the set of all points x comma f of x. So this maybe is 1 comma 1, and then there's other things. Okay, so now what's the contour plot? Well, the contour plot just lives in R. So what's the preimage? Let's say what's the preimage of 0? Well, what numbers square to 0? Only 0. So 1 point equals 1 point, namely the point 0 in the input space R. And now let's say what's the preimage of, how about 1? What numbers square to 1? What are all the inputs that give an output of 1? 1 and minus 1. So there's 2 points. Those 2 points. Preimage 1 is 2 points. Okay, and I drew them. And even though this is the point -1 and this is the point 1, for contour plots I like to visualize like the value of the function hovering above. So both of these points have the value 1 hovering above them because both -1 and 1 are sent via the map to the number. -1 is sent to 1, and 1 is also sent to 1. So hovering above them are the points 1. Okay, and the rest of the contour plot is similar. That would be enough for this answer. Okay, let's do the next one. D, x goes to x squared, comma, x to the third. Okay, part D. X goes to x squared, comma, x to the third. So like 1 gets sent to 1, comma 1. 2 gets sent to 2, comma, oh no, that's wrong. 4, comma 8. Okay, so that's enough to get the handle of it. Now this maps a real number to a pair of real numbers. And so again, the contour plot is usually thought of as in the plane, but in this case, in this example, it's the input space. Well, it's always the input space, but in this example, the input space is just the real line. So the contour plot will live somewhere there, and the graph lives in, well, the input times the outputs, which in this case gives three-dimensional space. And for this is again one of our familiar examples that we'll see over and over. This is, the graph is going to be the set of all points input comma f of x, so x comma f of x, which becomes x comma x squared comma x to the third, all the points that look like that, which we can think of as the image of a parameterized curve. And it's the twisted cubic curve, and it looks like this. And that is in fact the graph of this map. So the graph is the twisted cubic. And we usually think about it maybe as the image of this map, but this map and this map are related. The twisted cubic curve is this geometric object, which is the image of this map, and it's the graph of this map. And so that is worth thinking about. Okay, so that's done with the graph. Now let's go to the contour plot. So the contour plot here is a little weird because usually contour plots are for maps that have the output just the real numbers, but here we have R2. So contour plot is the preimages, and so the preimage of, well, I have to pick an output. So let's pick the output 1, 1. In fact, there is a number which maps to that output, namely the number 1. And so let's say if this is 0, this is 1, this is -1 on our number line. Oop. 2, 3. Well, then the preimage of 1, 1 is just the point 1. So it's that one, that point. The preimage of 1, 7. 1, 7 is a point in the plane. It is a possible output, but it turns out this map will never hits that point. You know, the 1, 7 is like there. No, I don't know what I'm talking about, but it's anyway. The preimage of this is empty. There are no points, so it just doesn't get anything. We don't draw anything there. And the preimage of 2, 2 is empty, and really most of these preimages are empty. The preimage of 4, 8, well, that would be the point 2. So this would, hovering above it is the output value, 4, 8. Usually I think of hovering above it as a number, but in this case the output are pairs of numbers, and so I think of 4, 8 hovering above the point 2. Okay. That's it. That's my contour plot. And I included these examples because they are very confusing to me as a student. So just spend some time with these examples. They will clarify things for you on the future problems that we'll see. Yeah, okay.